Hi everybody. So I'm going to go over number 42 from chapter 3 in the Physics 1 textbook. So this is part of the week 5 homework, and I wanted to go over this one because this type of problem is very tricky and it's also incredibly important to know how to do it. Okay, so what we have going on in this problem is we have a soccer player kicking a ball from a distance of 30 meters towards the goal. Find the initial speed of the ball if it just passes over the goal 2.4 meters above the ground. So if it's right up here at 2.4 meters, with this being 30 meters, given the initial direction to be 40 degrees above the horizontal. And then we want to find V naught. Okay, so that's kind of the situation we have here. And I think that's it. So let's see what we know about the motion in the x direction and the y direction. So in the x direction, we know that, we know that V naught in the x direction is, this is our adjacent, right? And so we use our SOHCAHTOA. So we see adjacent over hypotenuse. So this is our adjacent is the x, and our opposite is the y. So V naught in the x direction is going to be V naught times cosine of 40 degrees, because it's the adjacent over the hypotenuse. And V naught y is going to be V naught times sine of 40 degrees. Our delta x is 30 meters, and our ax is 0, right? Because we don't accelerate in the x direction. We ignore air resistance right now. And delta y is going to be 2.4 meters. And then the acceleration in the y direction is going to be 9.8 meters per second squared. Now you can put this negative here, or you can change it to negative g, and then have it kind of built into your formula. Either way is fine. We also need our kinematic equations for this one. So we know delta x equals v naught t plus 1/2 at squared. And then I think that's actually the only one that we need here, so I will stop there. So for this one, because our acceleration is 0, we can actually get rid of this part. And so we can just say that delta x equals v naught t. And then on these type of problems, it's really nice to use time as a bridge to get from your x direction to your y direction, because the time is the same for both. So what we can do is we can solve this for time. So we get time equals delta x over v naught in the x direction. Okay, now I'm not going to plug it in as this yet, because the algebra on this one is the most challenging part, and having this in there just makes it, having this in there makes it even trickier in my opinion. So that's why I'm doing that, as you will see shortly. Okay, so now we need to look at the y direction, and now we have a time, right? We have t equals delta x over v naught x. So now we can use this for our y direction. So we can say delta y equals v naught y times t plus minus 1/2 gt squared. Okay, so then, did I plug everything? Yeah. Okay, so now I can go through and plug in things more specifically. So they're basically just the time. So delta y equals v naught y times delta x over v naught x minus, I'm going to put the 2 on the bottom, the g on the top, and then I'm going to say delta x squared v naught x squared. Okay. Now I'm left with this algebra mess. So what I'm going to want to do is I'm going to want to get all the v naughts together. So I'm going to start by subtracting this over to here, and then I can kind of finish up the algebra and move everything else over from there. So delta y minus v naught y delta x over v naught x equals negative g delta x squared over 2 v naught x squared. Okay, so that's progress. Now I can multiply both sides by this 2v naught x squared, and then I will have all my v naughts over here. So I would have 2v naught x squared times delta y minus v naught y delta, oops, actually, I'm going to do v naught y. So one of these is going, oh, I needed the 2 in there too. Whoopsie, whoopsie, whoopsie. Okay. 2. Now one of my v naughts is going to cancel when I multiply it by this one. So I'm going to have v naught y, v naught x, delta x. And I don't have anything under the fraction bar anymore on that side. So that's pretty cool. Equals negative g delta x squared. So now I want to factor out these v naughts, but I can't just leave these y things here. So now I have to plug these guys back in. But I'm actually going to plug them in without the 40, just because I want to steer clear of numbers for now, and I'll put those back in at the very end. So now we've got 2 times v naught squared cosine squared theta delta y minus 2 v naught squared, because I've got v naught, and then cosine theta sine theta times delta x equals negative g delta x squared. Okay. Now I can factor out my v naughts. So v naught squared times 2 cosine squared theta delta y minus 2 cosine theta sine theta delta x equals negative g delta x squared. Now I can divide both sides by this thing. So I get v naught squared equals negative g delta x squared over 2 cosine squared theta delta y minus 2 cosine theta sine theta delta x. And then I can just take a little shortcut and square root this thing. And then I can get my calculator and I can say, okay, so I've got 9.8 negative times delta x squared 30 squared is that. I'm going to store it that. Whoops, okay, it's still there. And then I'm going to say 2 times 40 cosine squared times, what's my delta y, 2.4 minus 2 times 40 cosine times 40 sine times 30 equals that crazy number. Store that. And then I can do recall 1, which was this thing, divided by recall 2, which is this thing. And I get that. And then I square root it. And I get 18.16 or 18.2 meters per second is our V naught. So keep practicing this one, keep watching this video, work through it with me, make sense of it, learn how to do this. It's a very important type of question and it's a tough one. Good luck, and let me know if you need anything. Thank you.